All right, so on example D, we are trying to find the antiderivative, and all we have is the power rule, which doesn't look like it's even going to be useful here because this is a cosine function. So we got to make that look like a known derivative of something. And the problem is right now, that is an m divided by 2. We don't know how to find the antiderivative of a composite function yet, right? That's cosine squared of blob. So what you're going to have to do here is turn the angle somehow from an m halves into an m. So here is two identities that you need to remember that might work here. If you did a Pythagorean identity here, it really wouldn't help. It would just put it in terms of sine squared of m halves. But the power reducing identities are kind of the last set of identities that y'all as BC students need to know. Okay, so here's what the power reducing identities are. Sine squared of x is equal to 1/2 1 minus cosine of 2x, and cosine squared of x is equal to 1/2 times 1 plus cosine of 2x. These are basically derivations of the double angle identity for cosine. What it allows you to do is first of all, it allows you to write something that's squared in terms of something that's not squared. But if you also notice what it does with the angle, it takes the angle from a single x to a double x, which is what we want. We want to somehow double that angle m halves to make it an m. So the strategy would go this way. The 3 is a constant multiple. He's the writer. You're going to bring him out front. And if you replace cosine squared of blob, bless you, with this bottom identity here, it's going to be 1/2 times the quantity, 1 plus cosine of twice that angle. What's twice m halves? M. Yeah. And then with respect to m. So now that's going to make it much more manageable. Now in doing that, we picked up another writer. So we'll throw him into the front. Not under the bus. You thought that's what I was going to say. We'll throw him into the back of the truck, not under the bus. Now, you don't have to show this step, but I'm going to go ahead and show it for instructional purposes. So now we're ready to go. Now we have two terms, and one of them we know how to find the antiderivative using the power rule, and the other one is the cosine rule. So 3/2 goes along for the ride. Here's where you have to be careful, though, with parentheses or brackets. What is the antiderivative of 1 with respect to m? Right. It would be x, but in this case it's m, and then plus cosine is the derivative of what function? Sine. So the antiderivative of cosine is sine. Now this is where some students they're not sure if it's supposed to be negative or not. Remember that you can always check your answer. If we're saying that this is the original function, you can always check your answer by taking the derivative. What is the derivative of sine? Positive cosine, which is what we wanted. So we're not off by a negative. You could then close the parentheses after the sign of m and put plus c. That's typically where you do it. The real place to put it would be right here. But now if you were to distribute, what would 3/2 times c be? It would be still an unknown constant. So you don't have to do it that way. You could bring that parenthesis inside and just use it kind of plus c on the end. And then if you wanted to distribute the 3/2, that would be entirely up to you. All right, so those are the power reducing identities. Commit them to memory again if you forgot them. Notice they're both in terms of cosine. The easy way I remember is because they're both in terms of cosine, the cosine one gets the positive term, and the sine one, because it's in terms of the other one, has to be the opposite sign, negative. So if that helps you remember them, that's good. All right, so that was kind of the fun one. These are a little bit more routine. Here we have a product of two variable functions. Is there a product rule for anti-differentiation? If there is, we haven't learned it, and if there is, I haven't learned it either, so I can't teach you what I don't know. Turns out there's not, by the way. So in this case, what do you have to do? Distribute, expand it out. And so remember, you have to, please excuse your dear Aunt Sally, you have to expand the binomial squared before you distribute the z cubed. So z cubed times square multiply double square, right? Square multiply double square, square multiply double square. Square the 3, you get 9. Multiply, and you get negative 6z. Double, you get negative 12z. And then square the last, you get positive 4z squared. And all of that is dz. Now we can distribute the z cubed. 9z cubed minus 12z to the 4th plus 4z to the fifth. And now we have three terms, and they're all of the form a times z to the n. So the power rule works, right? So here we go. Z to the cube becomes z to the fourth, and then you divide by 4 or multiply by a fourth, and your coefficient becomes 9/4. That's incorporating the rider of 9 that was there with the new rule coefficient. Minus, leave a little space, z to the fourth becomes z to the fifth, divide by the new exponent 5, and you get a coefficient of 12/5. Plus, same thing over here, leave a space, z to the fifth becomes z to the sixth, divide by 6, you get 4/6, which simplifies to 2/3. Good. And you celebrate your success with a plus c on the right-hand side. And then the last one for this section. Never not first. Let's see. We have a quotient. Is there a quotient rule for anti-differentiation? No, there isn't. So, what? Force a 0 over 0? Oh, yeah. If you plug in a 7 to the top and the bottom, you do get 0 over 0, which tells you that x minus 7 is a factor of the top and bottom. This one's going to be a little bit harder to split up, right? You could say it's x squared over x minus 7 minus 5x over x minus 7, but that doesn't really help us out in this case because I can't simplify each term down to a power of x. Whereas if that were just an x in the bottom or just a negative 7, that would actually work. So in this case, there's some other technique, and this one we call it as factoring. The top factors as an x minus 7, hopefully, times something. It would be an x plus 2? Yeah, all over an x minus 7. So factoring is one of those strategies. Now your x minus 7's divide out, and we get the antiderivative of x plus 2, which now is a real easy polynomial. X to the first becomes x squared with a 1/2 in front. 2 becomes a 2x, and then, of course, plus c. There you go. So those are basic anti-differentiation rules. Yes, Skylar? No, it wouldn't hurt, like for the casual person that is just coming up and trying to use the antiderivative, it wouldn't hurt to remind them, hey, don't use 7 because it's not in the domain. Yeah, we modified the domain, so it's not a bad practice to go ahead and list that there. If the x minus 7 were still in the denominator, we wouldn't need to warn anybody because it's built in, right? But since it's not built in anymore, that's a good thing to put. I'm glad you brought that up. Okay, any questions on antiderivative or solving differential equations or indefinite integration? All right, cool. We'll call that a done lesson.